Hi friends, in today's session we are going to start with our new chapter, that is coupling, clutches and brakes. This is Faizan Kagvi and I welcome you all to our lecture series of basic mechanical engineering. So let's begin with our first topic. So first topic is our coupling. Now as the name itself suggests that what is coupling? Coupling means to couple, which means to join something. So its purpose is to connect two shafts. One shaft will be a driving shaft, another shaft will be a driven shaft. So we can define coupling as a mechanical device which is used to connect or couple two shafts. It is used to make permanent or semi-permanent connections. Which means we can even say that it is used to transmit mechanical power from a driving shaft to a driven shaft. Okay, next we need to see types of coupling. So before seeing types of coupling, let us understand that what other uses of coupling are there. So we would say that it is also used to connect two differently manufactured units. For example, it is used to connect a shaft of a turbine and a shaft of a generator. In this case, we can say that turbine shaft is separately manufactured in one industry. Similarly, generator shaft and generator is manufactured in another industry, that is electrical generator. Right. Now what is our purpose? So generator requires a mechanical power and turbine is a power generating device that is going to generate a mechanical power. Which means in that case we need to connect both the shaft. Right. So how we can do that? So in that case the application of coupling comes over here. Similarly, the other purpose of coupling is to absorb certain jerk and vibrations. So every time whenever we are going to connect a machine, so we cannot directly connect a machine to the driving shaft. We need to use a coupling for connecting that. Also, coupling is used for automobile transmission in order to connect gearbox shaft to the differential shaft. Okay, so in that case universal coupling is used, which provides a flexibility. Also, coupling has a capability to provide mechanical flexibility, that is it can accommodate two types of misalignment, that is first is parallel misalignment and second is angular misalignment. So first type is a perfect alignment, which means two shafts are perfectly aligned in one line, and second misalignment, which means there could be two types. That is first you can see over here, that is I am showing a parallel misalignment between two shafts, and second is a angular misalignment between driving shaft and a driven shaft. So this can be easily accommodated by means of a coupling. Now based on that, there are two types of coupling. First type is called a rigid coupling. So when it is used, so it is used to connect two shafts which are perfectly in axial alignment. Now these are of three types. So let us see that. The first type name of a rigid coupling is sleeve or muff coupling. Second type name is split muff coupling. Split muff, as the name itself suggests, the muff coupling is divided into two parts. It has been splitted. And the third type is called a flange coupling. Now let us see next type of a coupling, that is our flexible coupling. Now the name itself suggests that flexible coupling is going to provide some flexibility, right? It is used to protect, or we would say to provide protection to the driving and driven machines against harmful effect produced due to misalignment of a shaft, which means certain jerk and vibrations can be easily absorbed by this type of coupling, which means this flexible coupling can accommodate two types of misalignment, that is first is a parallel misalignment and second is a angular misalignment. So as you can see, it is written that it provides protection against sudden shock loads and or shaft expansions. Now let us see its types. So first type is called a bush pin type flange coupling, second type name is a universal coupling, and third type name is a Oldham coupling. So all these couplings we are going to see in detail. So let's begin with first type of a rigid coupling, that is our muff coupling. So the diagram of a muff coupling, as you can see on your screen. So we can say that it is the simplest type of a rigid coupling. Now from which material it is made up of? So we would say that it is made from a cast iron and the design is very simple. Okay. So as you can see, a three-dimensional view and a sectional view of this coupling is shown, representing that there are two shafts, driving shaft and a driven shaft, and both the shafts are separated by a straight vertical line between them, which is a partition indicating end of driving shaft and a beginning of a driven shaft. Okay, now how a connection is provided? So we have used a key and a muff to connect both this shaft. Okay, so it consists of a muff whose inner diameter is same as the diameter of a shaft. The muff is fitted over the end of a two shaft with the help of a key. Okay, Now there is one problem in this type of coupling. The problem is that at the time of disassembly, it is quite difficult to separate two shafts. Now it will be problematic in a case when driving shaft is a turbine and a driven shaft is a generator. Changing a position of a shaft means we are actually changing the position of a machine, which is not convenient to do so, right? It will consume more time. So what is a remedy for this problem? So we would say that we can divide this coupling into two parts, which means the second type becomes a split muff coupling. Okay, so let us see that split muff coupling. As you can see, the diagram of a split muff coupling is displayed on your screen. So in this coupling, the muff is made into two halves, that is divided into two parts, and are made up of cast iron, and they are joined together by means of a mild steel stud, bolts and nuts. So you can see that upper half is provided, which is shown by yellow color, and lower half is shown by red color. Both the halves are connected by means of nut and bolt. Okay. So at the time of disassembly, we have to just remove nut and bolt. Upper half will be separated, lower half will be separated, and easily both the shaft can be disassembled. Okay, so now over here you need to keep in mind the power transmission chain. Okay, so how it is transmitted? So we would say a driving shaft will rotate, it will transmit that power to a key, which is providing a connecting link between a shaft and a muff. From a key, the power will be transmitted to the muff. From a muff, again a power is transmitted to the same key, and then finally from a key the power is transmitted to shaft D. So this is called a power transmission chain. Okay, in this way mechanical power will be transmitted from one part to the other part. Okay, let us see further. So we can see actually the advantages of this coupling is that assembling or disassembling of a coupling is possible without changing the position of a shaft, that we have discussed now, right? Okay, let's proceed further. So the next type of coupling is called a flange coupling. Okay, now in flange coupling, as you can see, this coupling is having two separate cast iron flanges. Each flange is mounted on a shaft end and keyed to it. So as you can see, the surface on which nut and bolt is provided, that surface is called a flange. Okay, and other portion which is smaller than a flange and even shown by a black color is called a hub, or we can even say a muff. Okay, so muff and flange both are integrated parts. Now this flange is connected with a shaft by means of key. Okay, so for this a slot is provided on a shaft, that is bottom half portion of a key part is provided on a shaft, and a upper half portion slot is provided on a inside a hub. Okay, so the two flanges are coupled together by help of a bolt and nuts. The projected portion of one of the flange and a corresponding slot on the other flange helps to bring the shaft into line and to maintain a alignment. Okay, now it is used for heavy power transmission at a low speed. Okay, now let's see the next type of a coupling. Now this is a type of a flexible coupling. Even its name is all-round coupling. So a three-dimensional view is shown in which two silver color flange you can see. Okay, and in between that red color is representing a disc called a floating disc. So compare this three-dimensional view with the sectional view shown over there. So you can see a driving shaft is shown and a driven shaft is shown. Both the shafts are at misalignment. Now which type of misalignment are there? So we would say parallel misalignment is there between two shafts. Now the blue color flange you can see is named as flange A, and the green color flange is a flange B. In between there is a disc provided. That disc name is a floating disc, which means, as the name itself says, that a floating disc is going to float, right? It is going to perform a motion. Okay, now there is a two extruded portion provided on a floating disc, that is called a tongue. So there is tongue 1 and tongue 2, as you can see represented by a white portion within the diagram. Okay, now both these tongues are arranged perpendicular to each other, and these both tongues are resting in a slot. Now let us discuss about a power transmission chain. So the power will be first transmitted from a driving shaft to the flange A, from a flange A to the tongue 1, right? That is, a tongue is a connecting link for flange A and floating disc. from a tongue 1 to floating disc and finally to tongue 2. From tongue 2, power will be transmitted to flange B and finally power will be transmitted to the driven shaft. So this type of coupling can only accommodate a parallel misalignment up to 5 cm. Okay, beyond this, if there is a misalignment beyond this limit, so we cannot use all-term coupling. Okay, in that case we need to make use of drives. So we have discussed about several drives, that is belt drive, gear drives and chain drives. Okay, now the most important thing which you need to keep in mind is that how it is going to accommodate the parallel misalignment. So we will say that for the particular position, let's say for this position of this floating disc, you can clearly see that tongue T1 is in a horizontal position in this way, right, and tongue T2 is in a vertical position in this way. Okay, so at that moment of time we will say that a floating disc E is going to perform a horizontal relative sliding motion in flange A. Okay, why? Because tongue T1 at this instant of time is horizontal. At the same time, we will say that floating disc is going to perform a vertical relative motion in flange B. Right? Why? Because tongue 2 at this instant is kept vertical. Okay, so we can say that because of this sliding motion, that is relative sliding motion between a flange and a floating disc, a power is transmitted from a driving shaft to a driven shaft. Okay guys, so I hope that you are clear with this concept. Okay, now let us read out. So it consists of two flanges, flange A and flange B, with slots and a center floating disc E. The disc E is having two tongues, that is tongue T1 and T2, kept at right angle. The tongue T1 is fitted in a slot of flange A and allows a horizontal sliding relative motion, while tongue T2 is fitted into a slot of flange B and allows a vertical relative sliding motion. This coupling is used in connecting two parallel shafts but not in alignment, which means parallel misalignment, and their axes are at some small distance apart. Okay, now let us see next type of coupling, that is called a universal coupling. Now, as you can see, the diagram is displayed on your screen. So it consists of two similar forks keyed on the end of the two shafts. These two forks are assembled to a center block by means of a pin. Okay. Now this coupling is used to connect two shafts whose axes intersect, which means this coupling is used to accommodate angular misalignment between two shafts, that is driving shaft and driven shaft. And specifically this coupling is used in automobile transmission system, which means this can even absorb jerk and vibrations. So along with the rotational motion, it is also going to give a freedom to change its angle, which means the angle between the two shafts can be easily changed along with the rotational motion. Okay, so this coupling is called a universal coupling. So you can see it is written, this coupling is used to connect two shafts whose axes intersect, and it is also used to connect two shafts where the angle between two shafts may be varied when they rotate. Okay guys, so in today's session we are keeping up till here. In our next session we will start with our new topic, that is clutches. Till then, stay tuned and thank you all.